Hello everyone. In this video, I'm going to go over some of the worksheet questions on hypothesis testing. There are several of them. As you will note on Canvas, there are several of these worksheets on hypothesis testing, starting with the first section of the chapter, and then we'll move on to a little more complex and harder problems on hypothesis testing. All right. So this is the first one. Let's see what they are asking here. It says, suppose that you are considering a hypothesis test for a population mean mu sub 0. Mu sub 0 refers to the null hypothesis mean. In each part, express the alternative hypothesis symbolically and identify the hypothesis as two-tailed, left-tailed, or right-tailed. Now, the first step in performing any hypothesis test is to state the hypothesis, whether it be the null hypothesis or the alternate hypothesis. You have to state both of them. Now, this question is just in general asking us to state null hypothesis. It does not pertain to a particular specific application problems, application problem that is. So we are going to keep our statements pretty general here. All right. So first it says state the null hypothesis. The way you state the null hypothesis is use the symbol for null hypothesis, which is H sub 0, stands for null hypothesis, followed by a colon, and then mu, which is the population mean, mu, and then equals. There's always an equal sign. Just a second, let me pull up my pen. There's always an equal sign in the null hypothesis statement. So mu equals, now, if we had a specific problem to work with, then we would put a value of the null hypothesis mean here. But because we don't have a specific value here, we have to leave it in general terms. So I'm just going to put this mu value, mu sub 0. All right, so this is how you state the null hypothesis. Keep in mind that the mu, or rather the null hypothesis, must always be stated in terms of the population mean, never the sample mean. All right, it's stated in terms of the population mean, so your mu should be mu and not x bar, which is the sample mean. All right, the whole idea behind hypothesis testing is to draw inferences on the population mean. All right, so make sure that whether it's the null hypothesis or the alternate hypothesis, you are always writing it in terms of the population mean. Now, part A says you want to decide whether the population mean is different from a specified value mu sub 0. So, over here for part A and also for B and C, they're asking us to write the alternate hypothesis statements. And the way you write it is H sub A for alternate. So H sub A. Now here, you of course you have to follow it with a colon, and then there should be a mu. All right, there should be the population mean symbol, and on the other side there should be a population null hypothesis population mean. But what is going to be different is the symbol that we put in between the two mu's. All right, now it says here you want to decide whether the population mean is different. All right, is different means it could be less than the population mean, or it could be greater than the null hypothesis population mean. It's different. In other words, it's not equal. So whenever the question says you want to contest, you want the alternate hypothesis is stating that it is different, you are going to use the not equal symbol between the two mu's. So mu not equal to mu sub 0. whatever the null hypothesis population mean is. B says you want to decide the specified value is less than a specified value mu sub 0. Again, it's H sub A. We are still working on alternate hypothesis. So H sub A colon mu, and then on the other side also there's going to be the null hypothesis population mean. But the question here says, part B says, the specified value is less. So you have to use the less than symbol between the two means. And finally, it says you want to decide the specified value is greater than a specified value mu sub 0. So it's H sub A colon, again the population mean mu symbol, but this time it'll be greater than mu sub 0. All right? So these are the three ways you state your alternate hypothesis, and but you will be using just one of them depending on the question. Alternate hypothesis will be one of these three. Now, as part of the same question, they had also asked us to identify the hypothesis as two-tailed, left-tailed, or right-tailed, right? So let's do that here. Whenever there is a not equal to sign in the alternate hypothesis, when it says it's different from a specified value, it is a two-tailed test, right? So it's going to be a two-tailed test, the first one, A. A is going to be a two-tailed test because if we have our curve here, all right, and with the null hypothesis at the center, when we say that the population mean is different, then we are stating that the population mean can be less than or it could be greater than. It could be the alternate hypothesis claiming that the population mean could be either to the left or to the right. Okay, so that makes it a two-tailed test. When the alternate hypothesis states that it is less than the null hypothesis mean, in other words, when there is a less than sign in the alternate hypothesis statement, that makes it a left-tailed test. All right, it becomes a left-tailed test. And when there is a greater than symbol in the alternate hypothesis statement, it's a right-tailed test. All right, it's a right-tailed test. In other words, with this diagram, let me do one for each of these two. So when the alternate hypothesis is stating that the null hypothesis, when it's stating that the population mean is less than whatever the null hypothesis mean is, then it's claiming that the population mean is less than, all right, is less than whatever the null hypothesis mean is. So that means it's a value to the left of the null hypothesis mean, and that's what makes it a left-tailed test. For the right-tailed test, the claim is that the population mean is greater than, that means it will be something somewhere to the right of the null hypothesis mean. So that's what makes it a right-tailed test. So this is two-tailed, where the null hypothesis mean, where the population mean could be on either side of the null hypothesis mean. Then we have the left-tailed, where we state that the population mean is going to be to the left of whatever the null hypothesis mean is, and the right-tailed is where one states that the population mean is greater than whatever the null hypothesis mean is. Now, question number 2 is a word problem. It's an application-based word problem, and followed by some questions related to this problem. So let's see what this problem is about. It's on agricultural books. It says here in 2005, the mean retail price of agriculture books was $57.61. A hypothesis test is to be performed to decide whether this year's mean retail price of agriculture books has changed from the 2005 mean. Question number A says, determine the null hypothesis mean. In other words, they're asking us to state the null hypothesis. So the form is still the same. For the null hypothesis, you begin by writing H sub 0 colon and then the population mean symbol, which is mu, equals. Null hypothesis always has an equal sign. So it's equal to whatever the mean retail price of agricultural books is. In this case, $57.61, 57.61. All right. So here we replaced the mu sub 0 with a value, with a numerical value, because we are working with an actual word problem. In the previous question, we had to write it in general terms because it was not pertaining to a specific word problem. Part B says determine the alternative hypothesis. To write the alternative hypothesis, it's H sub A colon and then mu. And then on the other side, you still will have your $57.61, but we have to decide what symbol we should put in between mu and 57.61. So let's reread the question, and from there we'll determine what symbol this should be. It says a hypothesis test is to be performed to decide whether this year's mean retail price of books has changed. So this is the key word here that will tell us what the alternative hypothesis is claiming. Changed means you will use the not equal to symbol. It could have changed for a lower price or it could have changed to a higher price. It could go either way. It doesn't tell us. It doesn't say less or greater. It just says whether it has changed. All right, so that for that we will use the not equal to symbol. Then it says classify this hypothesis test as two-tailed, right-tailed, or left-tailed. Now remember we said that whenever we have a not equal symbol in the alternate hypothesis, that means it is a two-tailed test. It's a two-tailed test because the population mean could go either way. It could be less or it could be greater than the present null hypothesis mean. That's what makes it two-tailed. So to classify, it's two-tailed. That's the answer. Now, part D says, explain what each type of error would mean. All right, so this is a little bit different from the questions we worked before. It says it's not just stating the null hypothesis mean. Now we have to explain our understanding of the two types of errors, possible errors one can make while performing a hypothesis test. Now, type 1 error. In order for a type 1 error to happen, the null hypothesis should be true. All right? So type 1 error means the null hypothesis, all right? So the null hypothesis is in fact true. Hypothesis is in fact true or correct, but it is rejected. All right, so we reject a true null hypothesis mean is what type 1 error is, but it is rejected based on the sample study. Rejected based on the sample study. All right, so that's the explanation of type 1 error. For a type 1 error, again, for a type 1 error to happen, the null hypothesis has to be true. For type 2 error, the null hypothesis should be false. All right. So if we have not rejected a false null hypothesis, then we have made a type 2 error. So the way we are going to write it is, in a type 2 error, the null hypothesis is false. Okay, is in fact false. Is in fact false or incorrect. But based on the sample study, we have accepted it. But based on sample study results, it is accepted. That is, it has not been rejected. It is not rejected. So in order for a type 2 error to occur, the null hypothesis must be false and we fail to reject it. All right. And when is it a correct decision? A correct decision is taken when just a second. Let me fix this here. Okay, a correct decision is taken when we do not reject a true null hypothesis. So a true null hypothesis is not rejected. So that's one case. When the null hypothesis is true, we do not reject it. We accept it. We keep it the way it is. Or a false null hypothesis is rejected. Okay, that's how it should be, and we have taken the right decision. Now, part E is still a question on the error types, but it is specific to the agriculture book example. All right. So here it says, now suppose that the results of carrying out the hypothesis testing leads, it should be leads. All right. You can put an S here. Let me just do that. Leads to rejection of the null hypothesis. Classify that conclusion by error type or as correct decision if in fact this year's mean retail price, the first situation says, equals the 2005 mean of $57.61. So let's try to understand what the situation is. It says that when it says equals the 2000 mean, that means the null hypothesis mean was actually correct. All right. So when it says today's mean retail price, this year's mean retail price is the same as the 2005 mean. That means the null hypothesis mean, mu sub 0, is true. All right. In other words, the null hypothesis mean is true. So when the null hypothesis mean is true, we can only make a type 1 error, correct? So let's see whether we made an error or not. It said the testing leads to rejection of the null hypothesis, all right? So in this situation, if we rejected the null hypothesis mean, that means we rejected a true null hypothesis, right? So we committed a type 1 error. So in the first case, right, we committed a type 1 error, That means a true null hypothesis was rejected. All right, so with reference to this question, this particular example, we can say that the null hypothesis mu, let me phrase it this way here, the null hypothesis mean was correct, but we rejected it, thinking that we rejected it. All right, thinking the price had changed. All right. Now, part 2 says if it differs from the 2005 mean of 57.61. Now, what does this mean? It means that the price has changed. This year's price has changed. It differs from the 2005 mean of 57.61. That means the 2005 mean is no longer good. It's not true anymore. All right, so that means the null hypothesis mean, all right, H sub 0, the null hypothesis is false. It does not hold true anymore in this year. So when the null hypothesis is false, it can only be a type 2 error, but let's see if there is an error at all or not. So when the null hypothesis is false, what decision was taken? It led to rejecting the null hypothesis. And that is the correct decision, right? If the null hypothesis is false, we should be rejecting it. So going back to our question, it says, what was the decision taken? The testing led to rejection of the null hypothesis. So when we have rejected a false null hypothesis, we have taken a correct decision. A correct decision. Okay, that is a false null hypothesis was rejected. So that means with reference to this particular example, we can say that the null hypothesis mean of $57.61 was false and it was rejected, right? Okay, so this is how you should answer questions of this type. Now, question number 3 is still on error type. So let's see what they're asking. Suppose that in a hypothesis test, the null hypothesis is in fact true. Is it possible to make a type 1 error? Explain. If the null hypothesis is true, the only type of error we can make is the type 1 error. All right. So your answer should be yes. A type 1 error occurs when the null hypothesis is true and it is rejected. It's not only can a type 1 error be made, it is the only kind of error that can be made when the null hypothesis is true. When null hypothesis is true, only type 1 error is possible. B says, is it possible to make a type 2 error? Explain. No. When the null hypothesis is true, we cannot make a type 2 error. For a type 2 error to occur, the null hypothesis must be a false. Null hypothesis is false and we fail to reject it. That's when type 2 error occurs. So your answer for this one should be no. For a type 2 error, the null hypothesis must be false. All right. Question number 4 says, suppose the null hypothesis is in fact false. Is it possible to make a type 1 error? Explain. No. If the null hypothesis is false, the only kind of error we can make is type 2 error. So here you're going to write for part A, no. For type 1 error, null hypothesis must be true. Must be true. Part B says, is it possible to make a type 2 error? Yes. It's the only kind of error you can make when the null hypothesis is false. So you're going to say yes, type 2 error occurs when the null hypothesis is false. And we fail to reject it. Rejected. It's not rejected, right? Now for question number 5, I will not be posting the solutions for this. It is very similar to question number 2 that I already worked through before. So you can just look that up and use the same logic to answer this question. All right. So I'm leaving this for you to practice on. All right. But if you have any questions, let me know.